All right, for today's deep dive, we are looking at a pretty serious long-range forecast. We're focusing on the severe winter weather risk outlook for Northern Eurasia. So that's Europe, West, and Central Russia, and the Caucasus for this coming December 2025. We've sifted through the climate boundary conditions, and the overall assessment is, well, it's a sobering high-moderate risk across that whole area. So our mission today is to figure out what's driving this, what specific synchronized climate drivers are stacking up to create this kind of outlook.
Okay, let's unpack this. We know the severity really hinges on two major global forces lining up. What's the foundation here?
Well, it's basically the perfect storm of remote connections. The first driver is a weak but persisting La Niña event out in the Pacific.
Yeah.
It's projected to have about a 71% chance of developing and then just sticking around through the winter.
But wait, if La Niña is weak, why does it become such a dominant factor in this forecast? That seems counterintuitive. That's the key question. On its own, it really wouldn't be. But it matters because of what it's lining up with. It helps facilitate the second, and I would argue the most important, driver. We're seeing signals for an unusually early and major disruption of the polar vortex, the PV.
The PV, okay, and for anyone listening, that's the gigantic atmospheric freezer door that keeps the absolute coldest air locked up over the Arctic.
That's a perfect way to put it. And the models are suggesting that door could, well, break down or disrupt.
As early as late November.
As early as late November and then persist right into December.
So freezer door opens, bitter cold starts spilling out. How does that translate mechanically over Eurasia?
This specific synchronization, the La Niña plus the PV disruption, it forces the jet stream to buckle. It strongly shifts the atmosphere into what we call a protracted negative phase of the Arctic Oscillation in the North Atlantic.
The AO and the NAO.
Exactly, the negative AO and NAO. And that right there, that is the risk amplification mechanism. It just channels that frigid Siberian air directly westward.
And that's where the real trouble starts. Because that deep, frigid air moves right over the unusually warm Atlantic and Mediterranean waters. You get that collision of extreme cold and all that moisture, and boom, the potential for major storms, heavy snow, and dangerous icing just skyrockets.
Okay, and this is where it gets really interesting for me, because these risks, they're not uniform across the continent, are they?
Not at all. It's very differentiated. We've identified two critical high-risk zones.
Where are they?
First, West and Central Russia. They're facing a high risk for sustained, heavy snowfall and prolonged blizzards.
And what keeps that cold air reservoir going?
It's a powerful geophysical feedback loop. You get rapid Siberian snowpack growth, which leads to high reflectivity.
High albedo.
Right, high albedo. And that just maintains the integrity of that extreme cold. It essentially keeps its own radiator running.
I also saw a note about damaging rain on snow events. Yes, that's a serious threat, ROS events. That's when rain falls onto an existing deep snowpack and instantly freezes. It creates this heavy, icy crust that is just devastating for infrastructure. And the second area, the Caucasus region, we've assessed as having an extreme risk.
Extreme? Why so high?
That's the topography. You have those complex mountains combined with long-term trends showing a significant increase in December precipitation there. Any strong storm is highly likely to generate cascading hazards.
So not just snow, you're talking about landslides, mud flows.
Triggered by rapid melt and saturation, exactly.
And we can't forget Western Europe. West of 25 degrees east. They won't see that sustained cold, but they're in for something else.
They're in for intense, short-duration cold outbreaks, a lot of volatility in that rain-snow line.
Which means severe logistical disruptions, flash freezing on roads, heavy wet snow bringing down power lines.
It's a different kind of high-impact event. So if we bring this all together for you, this entire forecast, this whole cold, stormy December scenario, it all hinges on one thing.
The polar vortex disruption.
That non-linear atmospheric event. If that fails to happen, if the PV stays stable and the blocking doesn't persist,
and the cold air just stays bottled up in the Arctic.
And everything pivots. We'd see a much milder, wetter pattern instead. That is the one critical dependency.
So here's the final thought on this. The sheer intensity of the cold air that might reach, say, Paris or Kyiv, it relies entirely on snow. On snow, acting as both an insulator and a giant reflective radiator thousands of miles away across Siberia. So just think about that. The reflectivity of snow you will never see is what fundamentally determines the storm tracks and the severity of winter for an entire continent. That connection is really something to mull over.